how wind is created, it goes from a high to a low pressure. So I kind of have green dots there. Air goes from a high to a low pressure. That's wind. And then there at the top, I made, oh, I guess it's better. Okay, so high to low pressure, and then that red arrow is indicating kind of the force, the pressure gradient force. It's associated with the high to a low pressure. And so that fourth thing up there, steep versus weak pressure gradient force. So those hash marks are isobars. So if your isobars are close together, we call that a steep pressure gradient force, and you'll have fast wind. And then in red there, if your hash marks are far apart, your isobars are far apart, then we call that a weak pressure gradient force associated with that, and you'll have slow wind. And Coriolis force looks like this over here. Coriolis force, it's created because the Earth is spinning or rotating, and Coriolis force deflects air to the right in our hemisphere, but to the left in the southern hemisphere. And the Coriolis force is strongest at the poles and weakest at the equator. So in chapter 10, when we talk about hurricanes, that's a significant. And then the force of friction, people are usually kind of know that's like rubbing, right? So it's force of friction is generally created by roughness, for example, the Earth's surface, and it works in the opposite direction as the motion. And then geostrophic wind, that is the upper level winds, generally winds that are blowing relatively straight between the isobars. They're kind of in the groove, I say. And then at upper elevations, that's kind of generally between lines of latitude. But you know, we have some waviness to those upper level winds too. But geostrophic winds are those upper level winds, those westerly winds. And then the anticyclone H and the cyclone L. So I kind of have two columns over here. H is an anticyclone, L is a cyclone. H, a high pressure, the air is leaving the center, and a low, the air is coming into the center. The third one up there, air moves clockwise around a high and counterclockwise on a low. And then the last one, I said anticyclones have clear skies, and cyclones generally have cloudy skies. Cool. And then wind direction, that's just like, usually we say that we describe the wind, the direction it's blowing from. So westerly wind is coming from the west, and north wind is coming from the north. South wind is coming from the south. And then just to remind you, the windrows, I drew my own windrows here. It's an icon, and the longer the length, it means the more the wind comes from that direction. But I kind of included the word prevailing here. Prevailing wind, that means what the wind usually is, prevailing wind. And then the Bayes-Ballott's law is best for at upper elevations, but it just says go ahead, and it's alphabetical. If you put the wind at your back and you hold out your left as an L hand, the low will be on your left, according to the Bayes-Ballott's law and the deflection from Coriolis force. And so then that means if you hold out your right hand, that your high will be on that side. And the last but not least, do I have anything for AeroVane? Oh, I meant to look that up. So, help me out. Is the AeroVane... Thank you. Because we had... There's one that goes... Is that the one that gives direction and wind speed? Yeah.
Sounds familiar.
We'll add it on here.
Device that resembles a wind vane with a propeller at one end, used to indicate wind speed and direction.
Okay, excellent. So I'll just put gives wind speed and direction. Thank you. Excellent. Okay, then on to the next chapter. And the first one, those Santa Ana winds, those are associated with the Rockies. They are what and Dirk, remember, addressed this. Basically, I think of a high kind of hovering over the Rockies, and then that high pressure forces wind down, but it's on actually the Pacific Ocean side of the Rockies, so it's the windward side of the Rockies. And anytime you get air going down, it's going to compress and get warmer, so this is a warm, dry air. And then my other thing up there, as I said, it aggravates their forest fires. For timing and everything's not good. And Chinook wind is similar to Santa Ana. It's also associated with the Rockies, but it's on the leeward side or the east side. So Chinook and Santa Ana's are downslope wind. Hovering high pressure is what I have over there. And so the next one, I kind of copped out, so all I did was bring in that figure from your textbook, and I drew kind of arrows. So you're going to want to know the Hadley, Ferrell, and polar cells, and know the prevailing surface winds, which I didn't mark them, but we have the easterly trade winds in the Hadleys, and then we have the westerlies or mid-latitude westerlies in the Ferrell, and then we have the polar easterlies in the easterly cell, polar cell, excuse me. And then the intertropical convergence zone is where you see that white there. It's near the equator, but it moves, remember, seasonally. The doldrums is, I sometimes forget where it is, but you see equator low and doldrums. So the doldrums are right there too. Semi-permanent highs and lows. Remember, we have that high right there between the Hadley and the Ferrell cell, and then actually we have two lows. We have a low at the intertropical convergence zone, and we also have a low there between the Ferrell and the polar cells. Monsoons, by definition, winds seasonally reverse themselves, and they create two seasons, a cold and dry and a warm and wet season. That's what a monsoon is. Polar front. That, and I think I drew it, it's right up there. Polar front is between the Ferrell and the polar cell. And ocean currents are created by the prevailing winds over them. And actually I have a figure coming up. So ocean currents, what gets that ocean moving? It's the wind over on top of it. And then we talked about upwelling. Although I don't have anything for El Nino and La Nina, I do have a question about upwelling. And upwelling is along the coast, specifically, I think I better add that. Oops. Cold, nutrient-rich water coming up from ocean deep. And I'm going to go ahead and add along. Let's see, it'd be west coast. W for west coasts. And in order for upwelling to occur, it needs a pretty strong current. And then the last one, I think this was a homework question. Why do our west coast generally have cold ocean water? And so I went ahead, and down here I have a little figure from your textbook. And I put, you can't see it very good, but can you see those orange H's? So I put kind of orange H's there. And if you picture around the H in the northern hemisphere going clockwise, then actually that kind of gets you, for instance, on our west coast in California, that gets you your cold water coming down. So that's, and if you can convince yourself in the ocean basins in the southern hemisphere, around H's, of course, they'll go counterclockwise. And again, you'll have that pole, that cold pole coming from the poles, water. Okay, chapter 8, air masses. And then kind of next to it, the term, I went ahead and put generally kind of know air masses are characterized by their temperature and their moisture. And then in purple I said, and so air masses are uniform, but they're kind of just uniform horizontally. That's to say if you go up in an air mass, it could kind of change, but one layer is all uniform. Let's see what else I got. So source regions, that's where an air mass is created. And in order to be a good source region, to create an air mass, to give it the right temperature and pressure, temperature and moisture, it needs to be large, it needs to be consistent or uniform, and it needs to allow air to sit there a while or dwell. And then I went ahead and brought in the 2 maps of source regions. So the one there on the left is the winter source regions, and the one there on the right is the summer source regions. And then I kind of went ahead in winter. Remember, that's the only season that we have continental Arctic air masses. And then the summer is the only time that we have continental tropical air masses. So actually that answers the next one. And then if somebody says we are under the influence of air mass, our weather is just air mass weather, it just means basically you've got a big old air mass hovering over you, and that's the weather. So if it's continental polar air mass, we'd have a dry cold. If weather, if it was a maritime tropical, we'd have warm moist weather. And then the next one, the 5 types of air masses, I listed there. Kind of get a handle on those. And then air mass modification. Basically, when an air mass leaves its source region, as it travels anywhere else, it's going to kind of exchange heat and moisture with the new region it moves over. So air mass modification, air mass picks up characteristics of the land it's moving over by exchanging heat and moisture. And then dry line, like I said, even though it's in chapter 9, I went ahead and put the answer here. So dry line is 2 air masses. It's a clash between warm and dry, so continental tropical, and warm and moist, maritime tropical. I'm pretty sure dry lines used to be in this chapter. Maybe not. I don't know. Anybody know why the flags are half-mast?
I have no idea.
Oh, I wonder if it's the thing that happened in, was it Belgium?
Suicide bombing?
Yeah.
Yeah, suicide bombing. Could be.
So chapter 9. So a weather front is the boundary between 2 air masses. And we talked about 4 weather fronts. They're up here. And so I went ahead in orange next to each weather front. Like for the cold one, kind of from right to left. For the cold one, I said there's cold air pushing. And for the warm front, I said there's warm air pushing. And looks like I have it in the wrong place, don't I? Like this up here. Let's see if I can erase it. this right here. I drew my thing in the wrong spot. So it should say warm air pushing that way, right? So this is warm air pushing. And if you see on the weather map that multiple colors alternating, that's a stationary front. And I call it a standoff. And the last one, occluded front, we talked about how it actually has 3 air masses, but to me what's significant in an occluded front is that cold air outruns the warm air in front of it. Occluded front. And then overrunning is associated with warm air going up and over cold air. So warm air going up and over that dense cold air. And then since I think it's kind of neat, the whole, associated with overrunning, then you can actually have these clouds in advance of your front. So the clouds in advance are the cirrus, and then cirrostratus, altostratus, nimbostratus. So it's kind of stuff we talked about in Unit 2. So high, the highest, and then the next highest, and then we have the middle flat cloud, and then we have the precipitating cloud. So tonight we talked about mid-latitude cyclones. Let's see what I got here. So I have a couple figures from mid-latitude cyclones, kind of from right back to left again. This first one, it's hard to see, but you see the A, B, C, D, E, F. So I would put something like that on my note card, the steps of a mid-latitude cyclone. Then over there on the left is kind of a classic. You see the purple occluded front, and you see the cold front and the warm front extending from the occluded front. And then I have, viewed from a satellite, it looks like a comma. It was a comma. And then we talked again about this kind of this meandering, these Rossby waves kind of. And we said we have ridges and troughs, and the highs are associated with ridges, and the lows are associated with troughs. And you might want to, and actually I think those last two go together. Remember tonight we again talked about in order for your high to stay a high, you need to have air coming back into it. So basically you have air coming down like that. In order for your low to stay low, you have to get rid of air and it goes up. So I think that's it. All right. Yay.